All right, so for 11.8, we're going to be dealing with polynomials and rational inequalities. To begin with, an inequality are the symbols less than, greater than, less than or equal to, greater or equal to. So all these we're going to be dealing with. We're going to be looking for what values of x make our inequalities correct or make our inequalities true. So an example, solve and graph the solution set. X squared minus x minus 12 is greater than 0. Two ways on how we can do this. Two ways. You just learned in the previous section how to graph quadratic. And what I mean with quadratic is my exponent is 2. Remember, one thing you learn is how to find the vertex, and another thing you learn how to find the aperture and how to find the intercepts. So let me have a good idea on the intercepts. Let me factor this. Let me go as x minus 4, x plus 3. And for us to graph, remember we used to have this as an equal sign. So for graph purposes, let me have this as an equal sign because you learn how to graph with an equal sign. Remember, I just factor it. Now in the factors, I'm going to let each of my factors equal to 0. So I get that x is equal to 4, x equals negative 3. Now in graphs, on the x-axis, I will find negative 3. I will find positive 4. I know my graph is open up because my first numbered, it's a positive. My first sign on my graph is positive. So I know it's open up. Roughly, I'm going to say, I don't need to find the vertex in this case, but roughly I'm going to say it goes like this. It is open up and I see my intercepts. I'm not quite finding my vertex, but that's how it would look like. Now, if you see, this thing is asking, when is this graph more than 0? So when is this graph above the x-axis? I'm going to say from negative infinity to negative 3. Because when is this graph above the x-axis? When is more than 0? But I also see it from positive 4 to infinity. There is a gap in between them, so I'm going to use the union. So my set is from negative infinity to negative 3 and from 4 to infinity. So that's using the graphs because that's your knowledge. However, there's another way we can do this as well. Let me erase all this. There's another way we can do this as well. We can just say, well, let me start by factoring x minus 4, x plus 3 is greater than 0. Now, find the values that make each of your parentheses equal to 0. And I get x equals 4, x equals negative 3. On my number line, I'm just going to find negative 3 and 4. And the way I'm going to do this, let me find out any number to the left of negative 3. So any number less than negative 3. Just to choose a number, I'm going to choose negative 4. And then I'm going to think any number between negative 3 and 4. Any number in between them. Just to choose one, I'm going to choose 0. And then any number bigger than 4. Just to choose one, I'm going to choose 5. It doesn't matter which one, just any number. And I'm just interested on the sign on my parentheses. So I'm looking at this thing, the one with the parentheses. I'm just interested on the sign. The first parentheses is, I'm going to use negative 4 for x. So x minus 4, remember I'm using negative 4 for x, so negative 4 minus 4. I'm just interested in the sign. I'm not interested in the number. Negative 4 plus 3, negative. So it's negative times a negative more than 0? Right, negative times a negative is positive. Is positive more than 0? Yeah, that's true. All right, for my second group, let's think of 0, x equals 0. So my first parentheses, x minus 4. 0 minus 4, I'm just interested in the sign. I'm not interested in the number. The second parentheses, 0 plus 3. That's a positive number. Is negative times a positive more than 0? Right, negative times a positive is negative. Is a negative more than 0? Nope. All right, so now we're going to try x equals 5, right? So looking at the first parentheses, x minus 4. So 5 minus 4, I'm just interested in the sign. 5 plus 3, I'm just interested in the sign. Is positive times a positive more than 0? Yeah, that's true. So now you guys can see my spaces in there. So my answer will be from negative infinity to negative 3. You guys can see my gap now. It's going to be from 4 to infinity. Notice I have the same answer I showed you guys earlier. Before was graphing, but now we have this other method. My answer are either going to be something like this, like we saw it, or we can have this. Now this is our looking at some of my parentheses. That's when I have the symbol greater than or less than. Now I'm going to use brackets when I have the or equal to part as well. Now let's take a look at this one. You guys try these at home. Those are your solution sets, and I even graphed them for you. Notice how on example A, my inequality is, it doesn't have the or equal to part, so I put parentheses. Notice how here I have the or equal to part. That's when I'm using brackets. Now, inequality, in infinities, they always have parentheses, no matter what sign you get. Infinities always have parentheses. By my negative 3 and my 2, I use parentheses because of my inequality sign. Now let's take a look at this one. I'm just going to factor this. I must have the right side equal to 0. So let me rewrite this as 2x squared plus 5x minus 12 is less than or equal to 0. I'm going to factor this. Remember, we do two numbers that multiply equals negative 24. Added is equal to 5. So I'm thinking of 12 and a negative. Oh, no. Two numbers that multiply equals 24, but added equals to 5. Thinking 3 and 8, negative 3, positive 8. Because my first number is not a 1, I'm just going to, in order for me to factor this, I'm thinking 2x squared minus 3x plus 8x minus 12. Looking at the first two terms, I factor in an x. So that gives me 2x minus 3. Looking at over here, I factor in a 4. Right, a positive 4. So that gives me 2x minus 3. So my factors are 2x minus 3, x plus 4. So I let 2x minus 3 equal to 0. I let x plus 4 equal to 0. I have that 2x is equal to 3. So x must be 3/2. And I get x equals negative 4. All right, so my number line. Let's put them in order. Negative 4 comes first. And 3/2 comes second. All right, I put them in order. So anything less than negative 4. I don't know. Let's think of negative 5. I'm going to let my x equals negative 5. Now, anything between -4 and 3 over 2. I'm going to let x equals 0. Now, I know 3 over 2 is 1.5, right? So anything bigger than that, I'm going to let x equals 2. And what I'm using is 2x minus 3, x plus 4 is less than or equal to 0. All right, let's try the first parentheses. 2 times -5 minus 3. All right, 2 times -5 is -10 minus 3. My first parenthesis is negative. -5 plus 4, that's a negative. Is negative times a negative less than or equal to 0? No. All right, let's try x equals 0. The first parenthesis, 2 times 0 minus 3 gives me a negative. My second parenthesis, 0 plus 4 gives me a positive. Is negative times a positive less than or equal to 0? Yes. Take a look at the last example. 2 times x, right? I'm letting x equals 2. So 2 times 2 is 4. 4 minus 3 is a positive sign. 2 plus 4 is a positive sign. Is positive times a positive less than or equal to 0? No. So the only solution that worked, the only set that worked was this one. So it's from -4 to 3/2. And I'm using brackets on this one because my inequality sign has that or equal to part. Try this one out. That's what you guys should get. Now let's see if we actually understand inequality signs. Now 2x minus 3 all squared. Doesn't matter what value of x we think of, because we're squaring it, it's going to become positive, right? Or 0, we thought, we make this equal to 0. So it's either 0 or higher. Now, is this thing squared? When is this thing more than -1? Always, right? So my answer would be from -infinity to infinity. That means every number in between. Always works. Because remember, when you square it, you're going to make it positive. Or 0 if the parentheses was 0. So 0 or higher. When is that greater than -1? Always. Now, my question here is, remember, when you square something, if the parenthesis 0 was 0 square 0, but if it's not 0, when you square, you convert it into positive. When is this less than -1? When is a positive number less than -1? Never. So I'm going to say, I cannot think of a number because never. So I'm just going to say my solution set in this case is empty. Never. It never works. Now this is for you guys to try at home. Now what about this one? X minus 1 times x plus 2 times x minus 4. This is less than or equal to 0. What values of x make each of my parentheses equal to 0? Right. I'm thinking x minus 1 equals 0. I'm thinking x plus 2 equals 0. I'm thinking x minus 4 equals 0. So the values of x that make my parentheses equal to 0 are 1, -2, and 4. So my number line, I'm just going to write my numbers from smallest to largest. I'm just going to say, let's call this my -2. Then is 1, and then is 4. I wrote them from smallest to largest. Now think of a number that is less than -2. I'm going to think -3. Think a number between -2 and 1. Any number. I'm going to think of 0. Think of a number between 1 and 4. I'm going to choose 2. Now think of a number bigger than 4. Okay. So having that said, let's take a look at our parentheses. The first parentheses, I'm going to think of x equals -3. I'm going to work the first area. X equals -3. -3 minus 1, that's negative. Once again, I'm just interested on the sign. My second parentheses, -3 plus 2. Right? -3 plus 2, that's also negative. -3 minus 4, that's also negative. And it says this is less than or equal to 0. When my amount of negatives is an odd number, like 1, 3, 5, 7, 9, when the amount of negatives is an odd number, in multiplication that is negative. So it's a negative number less than 0? Yes. Now, when the amount of negative numbers is an even number, like there's 2 negatives, there's 4 negatives, there's 6 negatives, there's 8 negatives, right? An even number, my result is positive. So let me say that again. When the amount of negatives is odd, my result is negative. When the amount of negatives is even, my result is positive. All right, let's take a look at what if x equals 0. 0 minus 1, that's a negative. 0 plus 2, that's positive. 0 minus 4 is a negative. I see how many negative signs I have. I have 2 of them, which is an even number. So my result, all of this is positive. Remember I said if the amount of negatives is an even amount, my result is positive. Now when it's a positive number, a positive number less than or equal to 0? Nope, it doesn't work. Now how about x equals 2? If x equals 2, looking at my first parentheses, 2 minus 1, positive. 2 plus 2, so positive. 2 minus 4 is a negative. I see how many negative signs I have. 1. It's an odd number, so my result is negative. Is a negative less than or equal to 0? Yes. Now let's try the last group. We're trying x equals 5. So my first parentheses, 5 minus 1, that's a positive. 5 plus 2, positive. 5 minus 4, that's a positive. So all of these are positives. It's a positive less than or equal to 0? No. All right, so which sections did it work? From negative infinity to -3. There's a gap in between. And then from 1 to 4. So from negative infinity to -2, and then from 1 to 4. Notice for my numbers, I'm using brackets because of my inequality sign. Now my infinity, I'm using parentheses. Infinities always have parentheses. Try this one at home. That's what you should get. All right, so first write the inequality so that 0 is on one side and there's a single fraction on the other side. We're going to be dealing with rational inequality, so we're going to be dealing with fractions now. Determine the numbers that make the top and the bottom of your fraction equal to 0. Divide a number line into intervals. Find the intervals that satisfy the inequality and consider the endpoints separately. Okay. Now what this mumbo jumbo said is, make sure one side is equal to 0. So I'm going to write this as -1 over x minus 3 minus 1 is greater than 0. No, notice I subtracted my 1. Okay, so one side must be equal to 0. Now I must have a fraction. Okay, just one fraction, not anything else. So I have -1 over x minus 3 minus my fraction. My whole number 1. I know 1 in a fraction is the top and the bottom are the same thing. I'm actually going to write x minus 3 over x minus 3. The top and the bottom are the same. The only thing is that I want to have common denominators. And I know this says it's greater than 0. So when I combine my fractions, I have an x minus 3. So that's good. I have an x minus 3 at the bottom. My minus sign, I'm going to change it to plus sign, and I'll distribute the negative to the top of my second fraction. When I combine like terms, I have negative x plus 2 is greater or equal to 0. Okay, so negative x plus 2 over x minus 3 is greater or equal to 0. All right, so now let's take a look on the top. What value of x makes the top equal to 0? You could do it the side. Like I said, I'm just focused on the top. Negative x plus 2 equals 0. Negative x plus 2 equals 0. Let me move the 2 over. Negative x equals negative 2. So the value of x that makes the top equal to 0 is 2. Now what about the bottom? What value of x makes the bottom equal to 0? 3. Okay, so now what I'm going to do, I'm going to do my number line, and I'm going to separate it into 2 and 3. I'm going to think of any number less than 2. 0. That's easy to work with. Any number between 2 and 3. Between 2 and 3. How about 2.5? Any number bigger than 3. How about 4? All right. Looking on the first, I'm looking at this part right here. Negative x plus 2 over x minus 3. If x equals 0, so on the top I have negative 0 plus 2. That's positive. At the bottom I have 0 minus 3. That's negative. It's positive divided by negative more than 0. I know positive divided by negative is negative. Is a negative more than 0? Nope. Now let's take a look at 2.5. Right. Negative 2.5 plus 2, that's a negative. 2.5 minus 3, that's a negative. Negative divided by negative, is that more than 0? I know negative divided by negative is positive. It's positive more than 0? Yes. See how I'm not interested in the number, I'm just interested in the sign. Now let x equals 4. Negative 4 plus 2, that's a negative. 4 minus 3, that's a positive. It's a negative more than 0? No. So my only solution, my only set where it worked is from 2 to 3. The way I will graph it is, I label my 2 and my 3. Now, one thing for my fractions, my inequality sign, if my inequality sign, it has the or equal to part, it makes the top a bracket. Because I'm always going to have a 0 on the right. If my inequality sign has the or equal to part, it makes the top a bracket. So I would have put a bracket on the 2 if it had the or equal to sign. Now the bottom, the number that makes the bottom equal to 0, always has a parenthesis. Whether my inequality sign has a or equal to part or not, the bottom side always has a parentheses because I cannot have a 0 at the bottom. So when solving rational inequality, any number that makes the denominator 0 must be excluded from the solution set. So that means I must put a parentheses always, no matter what sign I have on the inequality. You try this one at home, that's what you should get. Let me try this one out. I have x minus 2 over x plus 2 minus 2 is less than or equal to 0. Right, first thing, I let the right side equal to 0. Let me give myself some space to work. I must have a fraction. And as a matter of fact, I'm going to multiply top and bottom by x plus 2. So I have x minus 2 over x plus 2. The negative, let me give it to the 2. I have an x plus 2 at the bottom. So on the second fraction, let me distribute the negative 2. That gives me negative 2x minus 4. So when I combine like terms, I'm thinking 1x minus 2x, that is negative x. Negative 2 minus 4, that is negative 6. All right. What value of x makes the top equal to 0? I'm thinking negative x minus 6 is equal to 0. Have the negative x is equal to positive 6. So x equals negative 6. Negative 6 is what makes the top equal to 0. What makes the bottom equal to 0? 2. So I'm going to use some space here. Negative 6 and 2. Now, for us to try this out, remember, I'm going to be looking at this thing. I'm thinking of any number less than negative 6. I'm just going to call it x. This time, I'm not going to tell you which number I'm thinking of. It doesn't matter which one. You think of any one. I'm just going to think of any number less than negative 6. I'm going to think of a number between negative 6 and 2. Any number. I'm calling it x because just to show you the number doesn't matter. The sign is what matters. So I'm just thinking any number between negative 6 and 2. And then I'm thinking of any number bigger than 2. All right. Let's take a look. I'm thinking of a number less than negative 6, right? I'm looking at my first section. Any number less than negative 6. Negative of that number. The negative of a negative makes it a positive. So negative of a negative makes it a positive. Minus 6. Okay, so I got on the top, I have a positive. Now on the bottom, x plus 2, have a negative. Positive times a negative, is that less than or equal to 0? I know positive divided by negative is negative. So is a negative less than or equal to 0? Yes. Now let me think of a number between negative 6 and 2. Not telling you which number. You think of any number between negative 6 and 2. All right. Negative x. Keep in mind if the value you thought of is a negative of a negative makes it positive. And the negative of 0 is still 0. So you thought out of whatever value you think of x, any number between negative 6 and 2. All right. On the top, negative x minus 6. I have a negative. At the bottom, x plus 2. I have a positive. Is a negative times a positive less than or equal to 0? Yes. Wait. Let me restart on this one. doesn't make sense. Let's work this out. Let me work this one out again. X minus 2 over x plus 2 minus 2 is less than or equal to 0. I have that x minus 2 over x plus 2 minus, have my 2, but I'm multiplying this with x plus 2 and x plus 2. All right, so I have an x plus 2 at the bottom. On the top, I have x minus 2 for the first one. I have negative 2x minus 4 for the next one. So that gives me negative x minus 6 over x plus 2. So the values that I have, the value that make the top equal to 0, I have a negative 6, and then I have a negative 2. Okay. So I was thinking negative 6, negative 2. I thought of a number less than negative 6. Actually, when I was working this, I was thinking of negative 7. Right, negative 7, negative of negative is positive. Positive 7 minus 6 is positive. Negative 7 plus 2 is a negative. Yeah, this one works. Now, between negative 6 and negative 2, to be honest, I was thinking of negative. Oh, I see why. Now, any number between negative 6 and negative 2, any number, I'm going to think of negative 5. Any number. All right. Remember, I'm using this thing right here, negative x minus 2, minus 6. So negative of a negative is negative. Oh, so I have positive 5 minus 6, negative. Negative 5 plus 2, negative. Is a negative of a negative less than 0? No. Now, anything higher than negative 2, I want to think 0. It's easy to work. Negative x minus 6, that's a negative. X plus 2, 0 plus 2, that's a positive. Is a negative divided by a positive less than or equal to 0? Yes. All right, so I'm just going to say my numbers, the areas where it did work is from negative infinity to negative 6. And also, I'm going to omit my parentheses in my brackets right now. Also, from negative 2 to infinity. My infinities always have parentheses. Now, because my inequality sign has the or equal to part, the number that made the top equal to 0, so the negative 6, has a bracket. The number that makes the top equal to 0 has a bracket. Now, the number that makes the bottom equal to 0 always has a parenthesis. Now, if I was to graph this, this is my negative 6. Let's call this my positive 2. When solving a rational inequality, any number that makes the denominator 0, so any number that makes the bottom equal to 0 must be excluded from the solution set. That's why I put a parentheses. Now you guys tried this one at home. This is what you guys should get. So let me help you guys a little. Let's work this one out. Just do the first part. X plus 2, x minus 1, minus 5, less than or equal to 0. I must have a fraction, so I'm going to multiply top and bottom by x minus 1. and then that negative, I give it to the 5. So I have x plus 2 over x minus 1 plus negative 5x plus 5. So my fraction, I have an x minus 1 at the bottom. When I combine the x's, 1x minus 5x, and then 2 plus 5. So I helped you guys a little there. And that is what you guys should end up getting